So welcome to this session on numerical integration. We will learn about three types of numerical integration here. That is Simpson's 1/3 rule, Simpson's 3/8 rule, Weddle's rule, and how to apply them. So to calculate integral a to b y dx, the first rule is Simpson's 1/3 rule, where I equal to h by 3 y0 plus yn plus 4 times y1 plus y3 up to yn minus 1. These are the odd terms, plus 2 times y2 plus y4 up to yn minus 2. These are the even terms. And to apply Simpson's 1/3 rule, n must be a multiple of 2. Simpson's 3/8 rule says that I equal to the integral is 3h by 8 y0 plus yn, first term plus the last term, plus 3 times y1 plus y2 plus y4 plus y5 up to yn minus 1. So you have all the terms except multiples of 3. And then plus 2 times y3 plus y6 up to yn minus 3. That is 2 times the multiples of 3. So to apply Simpson's 3/8 rule, n must be a multiple of 3. Then you have the Weddle's rule, which says that I equal to 3h by 10 y0 plus 5y1 plus y2 plus 6y3 plus y4 plus 5y5 plus 5y6. So this goes like 1, 5, 1, 6, 1, 5, 1 and so on. And to apply Weddle's rule, n must be a multiple of 6. So we'll do a few problems on this. Evaluate integral 0 to 6 3x squared dx by dividing the closed interval 0, 6 into 6 equal parts and apply Simpson's 1/3 rule. So since we are dividing into 6 equal parts, length of each part is b minus a by n, that is 6 minus 0 by 6, which is 1. So we have 0, 1, 2, 3, 4, 5, 6, y equal to 3x squared. When y is 0, we get it as 0. When y is 1, it is 3. When y is 2, it is 12. So these are the values. And by Simpson's 1/3 rule, I equal to h by 3 y0 plus yn, we just saw this, plus 4 times y1 plus y3 up to yn minus 1, plus 2 times the even numbered terms. So this is h by 3, y0 plus y6 will be 0 plus 108, plus 4 times the odd terms will be 3 plus 27 plus 75, plus 2 times even terms will be 12 plus 48. And that will be 216. The same thing if you have to evaluate using Simpson's 3/8 rule. Again, by Simpson's 3/8 rule, I is 3h by 8, y0 plus yn plus 3 times y1 plus y2 plus y4. So you have all the terms except multiples of 3, and then 2 times multiples of 3 up to yn minus 3. So this becomes 3/8 y0 plus y6 plus 3 times y1 plus y2 plus y4 plus y5 plus 2 times y3, because the last term is already taken here. So substituting again, you get it as 216. What happens when you apply the same thing to Weddle's rule? So Weddle's rule is I equal to 3h by 10 y0 plus 5 y1 plus y2 plus 6 y3 plus y4 plus 5 y5 plus y6. As I told you, you'll take 1, 5, 1, 6, 1, 5, 2, 5, 1, and then it goes on like this. So you will get 0, and substituting the values, you get it as 216. Coming to the next problem, evaluate integral 0 to 1 dx by 1 plus x squared using Simpson's 1/3 rule, taking 4 equal parts. So n equal to 4, so h equal to b minus a by n, that is 1 minus 0 by 4, which is 1 by 4. So your points are 0, 1 by 4, half, 3 by 4 and 1, and y is 1 by 1 plus x squared. At x equal to 0, y at the point 0 is 1. At x is 1 by 4, y is 16 by 17. At x is half, it is 4 by 5. At x is 3 by 4, it will be 16 by 25. And at x equal to 1, it will be 1 by 2. So these are the values y0, y1, y2, y3, y4. So again, by Simpson's 1/3 rule, the integral will be h by 3 y0 plus y4 plus 4 times y1 plus y3 plus 2 y2. Substituting, you get 0.7854. Hence deduce an approximate value of pi. Now integral 0 to 1 dx by 1 plus x squared, you know, is tan inverse x within the limit 0 to 1. And this is, by your calculation, it is 0.7854. So this is tan inverse 1 which is 0.7854 because tan inverse 0 is 0. So pi by 4 is 0.7854 or pi is 3.1416, which is the value of pi which you use in problem solving. Okay, the next problem, evaluate integral 0 to 1 e raised to 1 by x dx using Simpson's 3 by 8 rule. So here let n be 3, so h is b minus a by n. Simpson's 1/3 3 by 8 rule, n has to be a multiple of 3. So let n be 3, so h will be 1, so you get points 1, 2, 3, 4. Now by Simpson's 3 by 8 rule, I equal to 3h by 8 y0 plus yn plus 3 times all the terms except multiples of 3 and then 2 times multiples of 3. So this is 3h by 8 y0 plus y3 plus 3 times y1 plus y2, and these terms are not there because you only have terms 1, 2, 3, 4. And fx is e raised to 1 by x, so y0 will be e raised to 1, which is 2.7183. Substituting, we get the values of y1, y2, y3. And substituting, you get integral 1 to 4, e raised to 1 by x dx will be 3 by 8 of, substitute these values, you get 4.9257. So that concludes the first session on numerical integration, where you have learned 3 types of rules: Simpson's 1/3 rule, 3 by 8 rule, and Weddle's rule, and how to use it in problem solving. Thank you.